What is going on, everyone? So, once again, struggling to figure out the technology here, but we're up and running. Oh, it's just now 5 o'clock, so we're right on time. We're good. All right, welcome. I'm Will Button, and this is DevOps for the rest of us, where each week I am taking you through building out the AWS infrastructure that I'm using to launch my own product. And just along the way, I'm sharing what I do with you and hopes that you gain some DevOps skills for whatever purposes you may want those skills for. So let's talk real quick about what we did last week. We did a little introduction to DevOps. We talked about what DevOps is and why it benefits us. Last week was the first live stream, so that was pretty cool. I had a goal set there. My goal was to have 10 people watch the live stream, and looking at the analytics afterwards, I actually had 11. So I'm pretty pumped about that because I beat the goal, right? So this week I've got a goal set for it too. This week I am setting it up for my goal for having 10 concurrent users again, which may not seem like an increase, but it kind of is because last week was the first episode, right? So some people watched it. Maybe didn't think it was right for them, so they're not going to come back this week. Some of y'all maybe are back because you did enjoy the content and you want to see more. And maybe you shared it with some friends and told them about it, and so those friends will come in and replace the people who aren't returning this week, which gets us back up to 10. Speaking of which, I talked with Prachi after the episode last week, and she had some great feedback, and she also told me that she shared it with some of her friends as well. So thank you, Prachi. I really appreciate that. If you did watch last week's episode, or if you're going to watch this week's episode or live stream, be sure and head over to DevOpsForTheRestOfUs.com and sign up for the mailing list, because at the end of every live stream, I'm doing a transcription of it and then linking different parts of the transcription back to the YouTube video where it's saved on YouTube, so you can jump back to different parts if you want to refer to something in there. All right, so let's get into the stuff for this week. So we're going to be building on the stuff that we talked about last week. Last week we talked about a little bit about what a VPC is and why we need that. So if you didn't watch last week's live stream, it's available in my YouTube channel, but I'll touch on some of the highlights there, so you'll still be able to follow along this week. So the first thing we're going to do is actually going to be not related to the VPC, but related to CloudWatch metrics. Because here's the deal. We're setting up our VPC, which defines our own little sandbox inside of AWS, right? And then we're going to define some rules and policies about what gets into and out of that VPC. And then as I bring on different people to help me work on this, they're going to have different roles inside my AWS account. And those roles are governed by AWS policies. And even the infrastructure itself that's running inside of AWS, for example, my Docker containers and my databases and the S3 buckets, all of those have different policies too that determine what devices are allowed to read from them or write to them or make configuration changes to them. And so those policies are really, really important for our infrastructure. So we've got to kind of keep a tight control on them. We don't want them changing without our specific intent, right? As a matter of fact, I know of a couple of different scenarios where someone has had their AWS account compromised, and the very first thing that the person who got into their account did was created their own user account and their own AWS policy to give them quite a bit of freedom inside this client's AWS account, and then went and launched a bunch of stuff, ran up a huge bill. I think they ran up like $14,000 in AWS fees in 24 hours before it was identified. So that just kind of helps to illustrate why we want to do this. So we're going to set up CloudTrail metrics that let us know anytime any of those policies are changed, right? All right, cool. let's just jump right into it. And so if you take a look at my screen here, I'm logged into my AWS account. And so we're just going to start by going into CloudTrail metrics. To get there, we're going to click on services, and then they're all listed alphabetically here. So we'll go into CloudTrail. So what you want to look for while you're in here is this default trail. It's going to be there even if it's a brand new AWS account. You're already going to have this default trail. And so that's the one we're going to be working with. And the way that billing works in CloudTrail is you get to use this first trail and one destination for free. So you can do this without incurring any charges. But let me take a little side trip here real quick. You might be wondering what CloudTrail is. So every time you do something in AWS, or every time something happens to within your AWS account for the configuration of it, it gets logged as an event for CloudTrail. So if we just click on event history, you kind of see it there at the bottom. But here's the full history. If you look at the history of my account, you can see there's a console login. You can see who performed the action, when it happened, the source, and even whenever you get down to some of the other things here, like this one was delete internet gateway. It tells you the type of resource that was affected and even gives you the name of the resource. So there's quite a bit of information in here about what's going on inside my AWS account. If you're going to try and scroll through that manually, you know, it can get a bit overwhelming. So what we're going to do, returning to our dashboard here, is we're going to set up some alerting to look for specific events on there. So to do that, we've got to go into our default CloudTrail. And the first thing we want to do is set this so that it writes to CloudWatch logs. And I'll show you CloudWatch logs a little bit more in depth here in just a couple minutes. But basically it treats this as a logging destination. So not only do the events end up over here in the event history, but they get written to CloudWatch logs, which enables us to do the things we're going to do next. So in your account, if you're setting this up, this is going to be empty by default. So you'll, instead of having an edit button, you'll want to click the new button, and you'll enable it, which kind of makes sense, right? And you're going to probably send this to a new log group, and then you're going to give it a name. So the name I gave mine was CloudTrail/default log group. Now it also needs permissions, which is kind of ironic because that's the whole reason we're here, is to keep an eye on our permissions. But we need to give this an IAM role. That what this does is this allows the AWS CloudTrail service to write to CloudWatch logs. Okay, so it doesn't have that permission by default. And so whenever you do this, you're going to check new, and then it's going to prompt you to create that role for you. And that's the way I recommend doing it. And what that's going to do is it's going to create that role, but it's going to be a really tightly permissioned role so that the only thing it allows is this CloudTrail to write to your CloudWatch logs bucket, right? And then you'll hit save, and that'll be going and up and running for you. So that's going to turn on CloudWatch logs. So the next thing we want to do then is we're going to go take a look at CloudWatch logs. All right, so if you haven't used CloudWatch logs before, I'm kind of a fan of it. If you've used something like Splunk in the past, or even Elasticsearch for logs, those are pretty full-featured. And CloudWatch logs has really been kind of far behind when compared to those two guys. But the new improvements of it are actually getting kind of nice. So if I go to the log groups here, you can see there's the CloudTrail log group that I created. And, you know, it's got my picture in the way there, so I wonder how I can get rid of that. Oh, look, there it's gone. Right on. Sweet. All right, cool. Yeah, so there's the CloudTrail default log group, and if we click on that, There's individual log streams, so it kind of does some little log rotation in here and writes to different streams. We can just click this big orange button that says Search Log Group, and it's going to load all of the entries up for us. And if you click on one to expand it, you can see basically what it's doing here is it's creating a timestamp and then a JSON payload that contains all of the information we saw over in the CloudTrail dashboard. So this is what we're going to be filtering against. Another quick detour here. This is a pretty horrible interface. This used to be your only interface for CloudWatch logs, but they now have CloudWatch Insights. It's right below that. And so if I click on that, I can choose my default log group here because that's the one I want to query, and I can run it. And so that returns some stuff, still kind of crappy looking, right? So I can actually do like this sort of pseudo SQL type syntax here. So I can grab the event type, and I can grab the event name and event source, which I think was all that we saw on the CloudTrail dashboard. And so now it's coming back a little bit cleaner. That's a little bit nicer looking, right? And then, if you want to take it even further, I'm going to get rid of that limit because I don't really care about that. I can filter this to be, let's say, event name is equal to describe target health, just because I can see that one on the bottom of my screen. And then I can run query. And when that returns a filtered list of the logs that match that event. Then when I click the little plus sign here, you can see all the details there, including the raw @ message, which is our original JSON payload. All right, cool. So that's CloudWatch. Yeah, CloudWatch Log Insights. Going back to our log group here, getting us back on track. The thing that we're going to do here is we're going to create a metric filter. All right, so now what a metric filter is going to do, you can see I've got 2 of them created here already. We're going to walk through creating another one. I'm just going to click Create Metric Filter. So I showed you the CloudWatch Insights for a specific reason, just to give you some ideas of how I can filter different logs for different events, which is exactly what we're going to do here. I'm going to enter in a filter pattern, and then we'll take a look at the filter pattern to see what I did. I've actually got it saved here. So we'll just grab that. And I'm going to paste that filter pattern in right here. Let's go back and take a look at it though. All right. So it's kind of using like a jQuery style syntax. We've got $., and we're taking the event source where it's equal to IAM.AmazonAWS.com, so identity and access management. Basically, it's coming from the IAM portion of the AWS console or application, and then we're doing a logical AND, so it has to match this source, and the event name is we want to look for anything that starts with add, then a logical or, anything that starts with attach or change or create or deactivate or delete. Kind of getting the idea here. I think I've actually got detach in there twice, huh? Oh well, doesn't matter right now. Enable, put, remove, set, update, upload, and then put star policy. So basically what that's saying is it's creating a metric filter for anything that comes from IAM.AmazonAWS.com and the event matches one of these events that we've listed here. Right? So that's going to catch if someone adds a new IAM user, or if someone changes an existing policy, or someone removes a policy. Basically anything that changes our permissions model that we've defined in IAM is going to get caught by this metric filter. So let's actually grab these guys here. I grab all those, yeah. All right. And I'm going to paste those in there. And those are actually messages that I just grabbed earlier from my log account so that I could test this pattern with the test button, just to make sure that some of them matched. And 4 out of 6 is correct because I modified 4 out of 6 so that they would match this filter. So that just tells us that it's working, right? Right. You guys still with me? Let me check the chat, make sure y'all aren't asking questions. So if you do have questions, go ahead and throw them in the chat. I will remember to check the chat periodically, and we'll go into deeper detail for anything that you've got here. All right, so we've got our filter set. I'm scrolling on the wrong window. So now click Next. All right, our metrics namespace. So this kind of gets into how we want to define this to look in our CloudWatch metrics. All right, so our metric namespace, we can give it something like CloudTrail metrics. That seems to make sense, right? The metric name itself, we'll give that to something that's similar to our filter name. So IAM permissions, and then the metric value. So our metric value, basically, we're going to be setting alerts on this, right? And alerts are set to go off at a certain threshold. So what we want to do is just set this to 1, so that every time this filter is matched, it sends the number 1 to the dashboard. Oh, and I need to give it a filter name as well. All right, so now we can hit Next, and we can create that metric filter. And here it is right here. So now I've got another one set up here as well, right? And let's walk through what this one looks like. I won't drag you through watching me try to create it, but I will tell you what it does. This one detects the root user login. So when you log into AWS, there's 2 ways to log in, right? There's a root user account that has unrestricted access to everything in your AWS account. And then there are IAM users, and you want everyone to be logging in, including yourself, using an IAM user. You really want to secure your root user so that no one uses that account. The reason for that is just because it has unrestricted access, and if you lock it down, it minimizes the chances of that account doing something unintentional. All right, so what I did here is I created a filter pattern that looks at signin.amazonaws.com and looks for an event type of AWS console sign-in with the user.identity type of root. So basically root logs in, and then that's going to create a CloudTrail metric based on that. So what we want to do from here is this generates the metric data, but we actually want to create an alarm for it. So you see what I did here? I checked the little box to tell it which one I was interested in. Now I'm going to click Create Alarm. That's going to take me over into a new tab. And so what we're looking at here is it's kind of pre-populated some stuff. It gave the metric name, the one that we were working on. Sum is okay. You can pick different values here, sum, average, and then a period. We're just going to do it every 5 minutes because that's plenty. And then we're going to set our conditions of when this alert goes off. So we'll just use a static value as a threshold of greater than or equal to 1. Now remember, in the previous screen, we set the metric value to enter a number 1 every time that filter condition is met. So if this value ever gets to 1 or higher, it means it saw those events in the logs, right? Right. So we can go ahead and hit Next now. And now we got to tell it what to do when this occurs. I'm going to use an existing SNS topic, and whenever you pick it here, I've got one that's called alerts. But let's talk about SNS for a minute. SNS is the simple notification service. We'll actually go over here and take a look at it so you can see what that looks like. Just pop that into a new tab. I've got some topics defined here. The alert topic is the one that we're using. You can create a new one from this dashboard. Basically what it does is it allows you to create a subscription for alerts. So you'll create the topic and then create a subscription, and then you get different protocols of what you can use to define that. The one that I'm using is email. So every time I send a message to this topic, it sends an email to anything that is subscribed to that topic, which happens to just be my personal email account, it works. But there's a whole ton of other options you can do here. Anything that accepts an HTTP or HTTPS payload can be used. You can use Amazon SQS if you want that message queued up somewhere, or you can even fire a Lambda function to respond to this event based on the so whenever a message is sent to this topic, it will invoke that Lambda function and send a payload with it, and then you can take action based on the response or based on the data in that payload. So for this alert, we're just using my alerts channel, which sends email to me, right? We're not doing any auto scaling and any AC2 actions because it's just notification. We'll hit next, and then we'll just give this a name because we're just doing this for demonstration purposes. And this alarm description right here is really important to fill out correctly, because ideally these alerts aren't going to be triggering on a regular basis. If they are, that's probably a good indicator that you should check out what's going on in your account. So, every 6 months or maybe once a year, once every couple years, this alert's going to fire. And by that time, you're going to have long forgotten what the hell this thing was supposed to be doing. So do future you a favor and put a really good description in this alarm description box, so when you get that email a year from now, you actually know what the alarm is trying to tell you about. So we'll click next, and we are good to go. And that's going to set it up. Actually, let me show you real quick what that looks like, because you might have noticed I was signed in, or I am signed into my AWS account as the root user. So when I signed in, a few minutes later, I got this email, and here is the here's the description. No, that's not the description. Oh, here it is, right here. This is the description. That's kind of small text. Can I put that bigger? Nope, doesn't take the hotkey. Anyway, the description's right here, and basically I just put the AWS console's been logged in, and then I included the URL to the dashboard so that I can just click that link and it takes me right in, and I can see what triggered that alert. So that's how CloudWatch metrics alerts. So what we did there is we created a CloudTrail metric, and then sent that to CloudWatch logs data, created a metric filter to filter on specific events, and then tied those events to an alert that sent a message to an SNS topic whenever that alert condition is met. I think I covered this in the beginning, but I'll say it again because it's the whole reason we did this. The reason is because we're getting ready to build a lot of the infrastructure for my AWS account for this product that I'm building. And the infrastructure shouldn't be changing. It should rarely change, if at all, once we go through this work. And if it does change, I want to know that it did, and I want to know why. And so that's what this alert is for. All right, cool. So that's that. I'm going to grab some water real quick. And now we're going to create our VPC. So to do that, we're going to go into VPC, and let's actually do a quick check here, a quick reminder on what a VPC is. So inside of our AWS account, or let's say inside AWS, this is AWS, right? We're going to be talking about different things here. We're going to be talking about regions and availability zones, which are important to how we set up our AWS account. So region is the part of the world where your AWS account is. I'll show you here real quick. If you click this little drop-down menu, you can see all the different regions that AWS has available. I use the Oregon region. You might be building yours in North Virginia or Ohio or one of the international ones. Doesn't matter. Just know that different regions exist. So we're going to say we're in Oregon here because that's where I built my stuff. So now in the Oregon region, there are different availability zones. So I'm just going to draw some lines down here, and I'm going to write down at the bottom AZ1 for availability zone 1, AZ2, and AZ3. So an availability zone in AWS has certain guarantees with it. AWS doesn't guarantee that every availability zone will always be available, but they do guarantee that they'll always have at least one availability zone available. So what that tells us is we want to make sure as we build out our infrastructure, let's draw a little whale here. It's a pretty poor looking whale, right? It's probably a good thing I didn't go into art. So we've got this Docker container here represented by a defective whale. And there's another one, and there's another one. And so what that's telling us is the availability zones is telling us that we want to make sure we're operating our services in multiple availability zones so that if one of these availability zones goes away, then our services can still continue to operate because we built it across 3 availability zones. All right? So that's why that's important. To implement that, we're going to build our VPC. And if you remember from the last live stream, the VPC is just a private sandboxed area where we control what goes in and goes out, and we use private networking inside of that. We're going to build that VPC to span 3 different availability zones. Now you can build it to span more. I don't actually know how many availability zones are available in each region, but you can make this as complex as you want it to. 3 really seems to be like a good number in my opinion. I wouldn't do 2 just because then you got 50-50 chances, but 3 is a nice round number. And 3 also works out well for your fault tolerance, right? So if we look at this from a fault tolerance perspective, if let's say that I was only running these 2 Docker containers here, and one of them crashed completely, then 100% of my traffic would be going to this remaining Docker container, which puts it at risk for being overloaded and causing it to crash as well. But if I'm running on 3 Docker containers and one of them goes away, then I've still got 2 to handle the remaining load. All right, does that make sense? All right, cool. So back to our VPCs. We're going to build a VPC that spans 3 different availability zones, and each one of those availability zones is going to have its own IP address subnet, right? The IP addresses that we give it are going to fall within the non-routable IP range. And let me explain what that is and why that's important. And so sometimes this gets a little bit boring and a little bit dry. I'll do what I can to keep it entertaining. That's why I'm drawing these top quality art for you here which I'll make available for sale on my website if you want to buy high-resolution versions of them. But bear with me, because this is really, really important to understand in operating your AWS account. So we've got IP addresses, right? And I'm just going to zoom right in here. There are 3 different subnets that are considered non-routable IP addresses. We have 10.0.0.0 through 10.255.255.255. All right, that's the first one. The second one is 172.16.0.0, and it goes through 172.16.255.255. And then the third one is 192.168.0.0, and that goes through 192.168.255.255. And that one actually might look kind of familiar to you. If you've ever looked at your IP address when you're connected to your home router, you're probably getting something in this range right here, because that's where most consumer-grade cable modems and routers are configured to use their IP addresses. And for that exact same reason, I don't recommend using this scheme inside your VPC. Because what's going to happen is, let's say that your home IP address is 192.168.1.5, and then you build using this subnet your VPC, and your database server gets an IP address of 192.168.1.6. All right. Now, even though this is over in AWS and this is inside your house, you're not going to be able to talk to that, because every time you try to leave your house, your cable modem is going to look at the destination IP address and say, oh, hey, wait, that's here in the house, and it's going to turn that traffic right back around inside your house, okay? So it'll never work. So for that reason, I don't recommend using that, that subnet for your VPC. So we're going to actually use the 10.0.0.0 subnet, and we're going to build 3 subnets across 3 availability zones. So we'll have, and I might change this, I'm just making up numbers right now. So we'll have 10.0.10.1, 10.0.10.2. Nope, I screwed that completely up. .10.0.10.0, 10.0.11.0, and 10.0.12.0. So then that will give this complete subnet to this availability zone, this subnet goes to this availability zone, and this one goes to this availability zone. Make sense? All right, let's hope so, because we're moving on. All right, jumping back over to our VPC. So I'm on the VPC dashboard here, and you'll notice this button right here, Launch VPC Wizard. All right, so if I click that button, if I really click it this time, it's going to walk us through a couple of different scenarios for building a VPC here. One is a VPC with a single public subnet. Another is a VPC with public and private subnets. And then the last 2 are really kind of specialized with hardware VPN access and hardware. Yeah, those are the 2 options there: hardware VPN access with public and private subnets. So I didn't mention public and private subnets real quick. So let's talk about that real quick. We covered it briefly last week. But if we jump back over here and take a look at our stellar VPC diagram, so our VPC, in this 10.0.10.0 space would be considered a private subnet. and it's private because this is a non-routable IP address, meaning it doesn't exist anywhere out on the internet. Okay, but we also, and this is where we're going to put a majority of our AWS resources, is we're going to put it in there because it's private to us. But we also need some public resources, right? We need a public load balancer that can be publicly exposed to the internet and receive traffic from our customers, right? Because it really doesn't do much good to build a website or a web application if no one can get to it. So we're actually going to be breaking our VPC up into different subnets. They're going to be public subnets and private subnets. So in addition to the three that we drew down here, we'll do something like 10.0.20.0 as our public subnet here. And we'll do the same over here for these two as well. All right. So anything that has to get access from the public internet will go in our public subnet. Everything else goes in the private subnet. And then things that we put in the public subnet can talk to the private subnet. All right. So that's how that's going to work. So I chose to build a VPC with a public and private subnet. You can see it's already suggested a private CIDR block here. CIDR, if you're not familiar with that, stands for Classless Internet Domain Routing. VPC name, we're just going to call this livestream demo. And then, just like we drew out on the diagram there, it's recommending 10.0.0.0/24 for our public subnet and 10.0.1.0/24 for our private subnet. And I'm going to actually give these a little different name so that they stand out. So now it's asking about the details of our NAT gateway. I'm going to go over here and I'm going to click Use a NAT instance instead. And that's going to launch an EC2 instance that acts as my NAT. So let's talk about what a NAT is real quick. All right, jump back over here. Let me erase some of this. I hope y'all didn't want like printed copies of that because I just deleted it. That'd be horrible. It's gone forever. All right, so we've got our VPC here. I'm just going to draw one availability zone. We've got our public subnet and our private subnet. All right, our public subnet, we gave the address of 10.0.0.0/24. Our private, we gave 10.0.1.0/24. If you're not familiar with it, the /24 tells you how big this subnet can be. So a /24 means that you can use everything in this last digit here. So you can do 10.0.0.0.1 through 10.0.0.255. Okay? So if you had a /16, you could use both of those and so on and so forth. That feels like we're getting a bit off topic, but I thought you might want to know what it is. Okay, so our public instances, let's say we have a server right here. It's in our public zone. So outside of this here is the rest of the internet, right? So it's free to talk and receive traffic from the internet because it's in the public subnet. Anything in our private subnet, though, has no path to the internet because it's private, right? It's kind of implied in the name. So this NAT instance that AWS was just asking us about is a little box that we're going to put here on the corner that actually does have internet access, but it's outbound internet access only. So when this guy needs to access the internet, his traffic is going to be relayed to this NAT instance, which is going to send that out to wherever it needs to go on the internet, and when it returns, it will come back through that NAT instance to the instance, and that's how that works. So I said that it couldn't receive traffic, and then I told you that the traffic just came back in, right? That's because it's established traffic. What that means is the only thing that it will allow in is a response to a request that it sent out. So if someone was over here on their laptop, and had this guy's IP address, they couldn't communicate with it directly because it doesn't answer to that. So we set up a NAT instance, or we told it to set up a NAT instance. It is an EC2 instance, so we have the ability to SSH into it, and I'll need to give it my key pair name. If you're not familiar with key pairs, that's okay. Just smile and nod for right now, because we're going to cover that in more detail in probably the next couple of live streams. Service endpoints we're not using. As a matter of fact, we can just leave the rest of this as is. So that's going to create our VPC, which was pretty straightforward, right? I mean, aside from having to stop and talk about some concepts that I wanted to make sure you guys understood, it was really just, actually I think the only thing that we changed here was the name of the VPC and the name of the private and public subnets, and we didn't really have to change those. I just wanted to change them so that later when I go clean this up after the live stream, I know which ones to delete, and I don't bring a bunch of stuff down. So we're going to click Create VPC. Holy cow, we've been at this for 43 minutes. This one's running a lot longer. I apologize. I told y'all last week I was going to try and keep these short, and that turned out to be a lie. So let's take a look at one more thing for VPC, because I want to cover both of these. Oh, by the way, there's the VPC that we just created. The other way I wanted to show you to create it is through a CloudFormation template. All right. So now CloudFormation templates I like because it's something that's a text file that I can control, and I can commit this to version control. I can create a GitHub repo that has all of my DevOps type stuff, and I can commit this to that repo, and then I know exactly how my VPC was built. Now, if you haven't used CloudFormation templates before, they're just YAML files. So let's take a walk through it. We've got our description here, and I'll show you where that description comes into play. And then it takes some parameters, and so it takes an environment name parameter, VPC CIDR notation, and then there's a default here too. So I can go ahead and specify the default value I want here, which further refines my template. There's a public subnet 1. So this actual template here defines 2 public subnets and 2 private subnets, whereas the wizard that we use created 1 public subnet and 1 private subnet. So now we're defining 2. Each one of those are parameters to our templates. And then we have this resources section. That's what actually gets created. Those are the AWS resources, believe it or not, that get created inside of this template, or as a result of this template. So we create a VPC. The type is like an AWS type definition. Think of it as like a static type, sort of almost. And then it has properties that have to be filled out. You can see this bang ref here. So that's a reference to something called the VPC CIDR, which if we look, that's one of our parameters up here, right? And we can follow this through. We just got to complete the different properties that each AWS resource needed in order to complete it. So we've got our internet gateway. So this one builds an internet gateway instead of a NAT gateway. And then it defines our public subnets, type of AWS EC2 subnet. You see the reference to the VPC, the reference to the public subnet 1 CIDR, and the rest of those are the same because they're just different subnets. Here's our gateway elastic IPs, which are the internet gateways that get built for our outbound traffic. And then it creates the route tables as well. And for the sake of time and possibly your sanity, I'm going to avoid taking you down the world of routing right now. If that's something you're interested in, let me know, and we can definitely dig into routing a bunch more. Actually, I'm just going to go ahead and make a note to do that in one of our other live streams, because understanding routing is going to save you a lot of troubleshooting in AWS. But the route tables, and we'll take a look at the routing tables here in just a minute. So there's some outputs here. This is what happens whenever the CloudFormation template is completed. It shows you the values for the different things that it created. All right, so that's all defined via a YAML file, right? To actually build this, we're going to jump over to another AWS service called CloudFormation. And I'm going to click on Create Stack here. And we're going to use new resources. Got the template is ready. I'm going to upload a template file, and I'll choose the file. So there's my YAML file. I'll upload that. It's also going to do some syntax checking here as well. So if there's any errors in my YAML file, it will stop me here. And then when I hit next, here's where the magic happens, because all of those parameters we were just looking at are right here. So I can call this one livestream 2. Environment name. Actually, we want to give that something different. We want to give that. So the environment name, every AWS resource that gets created, which we looked at in the template there, the name of it will get prefixed with this text so I can track back where it came from. Here were the defaults that we saw built into the template. I can change those here if I want. That's no issue. If you're going to do it this way, I would recommend filling in the defaults in your YAML template and saving that rather than changing the defaults here, just so that you have some consistent tracking. Then we need to create some tags here, and I'm going to show you my trick for for defining which tags. So name, we're going to call this the livestream 2 VPC, and then we're going to add another tag. I'm going to give it the service is VPC. Environment is dev, as opposed to staging or production. Role is networking. And then team is going to be our DevOps team. So I chose these tags for a specific reason. Number one, the name. You got to have names for your stuff so you know what you're talking about. The service is either, for the way I do this, is the component or feature that it provides within AWS, or later when we start deploying applications, they're going to get these same tags, and at that point for service I use the name of the GitHub repo that contains the code for that service. Environment, it will be dev, staging, or production. The role is what role does this play in that in the service. So it's our networking layer for this application. If we were deploying a database server, the role would be database. If it were an application server, we could put application, or we could put the specific application feature that it could be serving as well. And then the team I put here as like some way to get a hold of someone who knows what this thing is when it blows up. And this is easy to remember because if you look at the first letters of these, it's NSERT or insert. And then, You always know which tags you got to have because you have to insert them. Pretty clever, right? Ha ha ha. The IAM role, I'm running this as my own account, so we're just going to use my IAM permissions to create it. And we can hit next. That's just a confirmation screen, and then we'll hit create stack, and that's going to go through and start creating it. So while it's doing that, let's go back over here to VPC real quick because I want to show you the route tables. Drag that down. So we'll look at our live stream public route table. That's the subnet that has public access, right? So there's two targets or two entries in the route table. 10.0.0.0/16. The target is local. What that's telling it is that if you see anything inside of this subnet address, then that's local to your own network. You don't have to go ask anyone's permission to get to it. It's right there next to you. The other target is 0.0.0.0/0, which means everything else in the world. So if you want to talk to anything in the 10 subnet, it's right there next to you, buddy. Everything else in the world, you got to go through this internet gateway. That's how you read the route table. If we look at our private one, it's very similar. Anything in the 10.0 subnet, it's local, right in the same VPC as you. Everything else, you have to go through this network interface, which happens to be the network interface for the NAT instance that we created. So that's how you can read the route tables. When you're troubleshooting something, if you've got an issue where you can't figure out why you don't have internet access, that's the way it usually pops up, then come look at your route table and verify that you have this wildcard route here that for external access is pointing to a valid interface. As a matter of fact, that's a clickable link, so we can go ahead and click on that, and that's going to pop us over to the EC2 management console and show us the interface itself. And here at instance ID, that's telling us the specific EC2 instance that it's connected to. And we didn't actually name it because we used the wizard, but it is that T2 Nano that we created as our NAT gateway. All right, so if we take a look at this, it's still in progress. So that's still creating. Let's see where we're at on my checklist of things we were going to talk about today. All right, we're doing good. This was the last thing I was going to cover. I just needed to complete because I want to show you one more really, really cool thing about CloudFormation. So let me talk about this while that's finishing up. The reason that I use CloudFormation versus the wizard depends on the application, right? Ideally, you're not going to be creating VPCs on a regular basis, right? It's going to be pretty infrequent that you're creating a VPC. So you can use the wizard, or you can create a template like this, whichever one you're more comfortable with, knowing that you're not going to have to do it very frequently. The exception to that is depending on the type of industry that you're in. If you're in a highly regulated industry like finance or healthcare or government, you're probably going to have multiple VPCs that one VPC for your production environment, one for your staging environment, and one for your development environment. That's where you really start to get the power of the CloudFormation template, because you're going to want all those to be the same, right? It doesn't do you much good to have a dev VPC and a production VPC if they're completely different, because you're not getting any benefit from that aside from keeping people out of production, right? But if you do it with the YAML template, then you can take that same YAML template, and if you remember, we picked the environment prefix there. You could prefix it with dev, staging, and prod, and use that same template to create multiple VPCs for your dev, staging, and production environments. So that's where it really gets to be powerful. So our VPC has completed over here. You can see that it says create complete. If we go back over to VPCs, we can see livestream 2 here is created. Now here's one thing that I wanted to show you on this. If I go into the livestream 2 private subnet, and I'm going to modify the auto assign public IP addresses. Right, so I'm going to tell it to go ahead and assign this a public IP, even though I know that this is my private subnet, and I'm going to save it, right? So what do? We had a defined VPC. I went in behind the scenes through the AWS console and I changed it. Did I tell anyone? Who knows? Did it break something? Yeah, who knows? So what I can do, though, is come back over here to our CloudFormation template, and under Actions, I can click Detect Drift. That's going to kick off a little process. Shouldn't take very long, so I can click View Drift Results, and look at that. I get some stuff that was modified. So what that tells me is that the VPC we created has been changed. Here's exactly what changed since we checked it. And then I can determine what to do about it. All right. So that's one of the other benefits of using the CloudFormation stacks to build your infrastructure. All right. That was what I wanted to talk about today for VPCs and CloudTrail metrics. So we did a couple things there. We set up metrics so that if anything changes on key parts of our AWS infrastructure, we get notified. And then I showed you 2 different ways to build a VPC and gave you some reasons as why you want to choose one versus the other. So let's jump into the final part here where we do our 5-minute Q&A. And so today's question actually came up this week from someone who hit me up and was talking about multiple income streams. I'm a huge fan of multiple income streams, and this is less DevOps related and more just career related. So the individual I was talking to is doing some side work in addition to their regular job, and she wanted to know, just some pros and cons of it, and we talked about this previously. So let me set some background here. I'm a big fan of multiple income streams because you might love your job, and it could be a great job, but it may not always be there. And so it's just kind of like diversification, whenever we build our 401k, we don't invest it all in one stock. I believe you should do the same thing for your income and have some other source of income coming in besides your normal job. And I'm not trying to advocate that you should be working all the time, though, right? You still have to balance the other areas of your life. And you've got to have this discussion if you have a significant other, a spouse, kids, you've got to make sure that they know what's going on and why you're doing it. The big reason to do it, though, is because for a lot of families or a lot of individuals, when they lose that primary job, they're completely screwed financially, and they're just hoping that they can land another job quick enough that it doesn't financially bankrupt them. And the numbers I saw earlier this week, we're at, I think, 14% unemployment right now, and that's just the start of it. So the odds of finding another job are, they're challenging. So multiple streams of income is just where you have some other source of income coming in. That can be doing some consulting work for a client or building a product that on the internet, the way that I first started doing it, creating videos. I've created a bunch of videos for egghead.io and pluralsight.com and caster.io and some work for Pact Publishing. And all of that, turned into multiple streams of income. And so the thing that I learned, I didn't actually know this when I started doing this, was it gave me freedom, because then I was not 100% dependent on my job to pay the bills. I'm the only one who works in my family, so I'm the only source of income, which was, a little, well, it wasn't pressure. It was just my job. That's what I did. But, having that sole source of income be my job put all of our eggs in one basket. And so then I started doing these multiple streams of income. It started working. It started getting successful. And then at one point, I realized, I didn't have to have my job anymore. It was cool. It was fun to do, but I didn't have to have it because our core bills were paid from the videos that I had recorded, in some cases years prior to that. And that turned into freedom, because then I started thinking about, what do I really want to do? And that's whenever I went out and started, building my own business pretty aggressively, and working for some startups that were pretty high-risk startups that had a signature. But, I was able to do that because I had the bills covered, and the project itself was fun and entertaining and exciting, and had a high risk of failure, but a high chance of reward too. And that was something I would never have had the ability to do had I not had multiple streams of income. So the TLDR of that is, I encourage you to do that, and do it in a manner that's that resonates with your lifestyle. If you're watching this live stream, you're probably into writing code, but your multiple streams of income don't have to be that. If you're into fitness, you can do personal training on the side, or if you're into art, you can paint art on the side and sell that. Whatever it is, just make sure that you don't have your financial security and the livelihood of your family all tied up into one source of income. And if you have a spouse or a significant other that both of you bring in income, it's a great conversation to have with them about, how you want to divide this work up. Is one of you really passionate about doing something? Is the other one got something that might turn out better? Just talk through different options, figure out what you can do. That's the 5 minutes for today's Q&A. I didn't really intend for that to take a single question, but there you go. That just means we have more questions to go through next week. So I'm going to wrap this live stream up. We took way longer than I thought I was going to. We're over an hour here. I hope you enjoyed it. I hope it was worthwhile. And so a little reminder for you, be sure you go to devopsfortherestofus.com and sign up, because as soon as this live stream's over, I'm going to start transcribing it. I will send the transcription out to the email list, and that includes links to the YouTube video